Okay, so one of the things that we really need to get a strong grip on is the values of our trig functions at stated angles and the values of our trig functions at the quadrantial angles. And if you know the value of one trig function, you know all 6 of them. On number 11, we've got an angle who has its terminal side on the negative x-axis. So an example of such an angle is 180 degrees, but any angle whose terminal side is over here. An example of an ordered pair that lies on that terminal side is, the ordered pair -1, 0. Now, you know our trig functions are defined as x over r, y over r, y over x, x over y, and so forth. When an angle is on one of the axes, then the r value is the same as the stated value. So here r is also 1. So the things that will be undefined will be things that have the 0 in the denominator, stuff that has a y in the denominator. So the ones that are not defined is the r over y entity and the x over y. R over y is our definition of the cosecant of whatever angle that is, and x over y is the cotangent of that angle. So these are the 2 trig functions that are not defined there. Okay, so you tell me, what if we had this angle? Which ones are not defined? Say at anything that corresponds to the positive y-axis. So an example of an ordered pair there. What's not defined there? Which 2 trig functions? Anything that has an x in the denominator, right? Tangent and secant. They're not defined when the angle is coterminal with the y-axis. Same deal would be for the negative y-axis or the positive x-axis. So these are the ones that are not defined if the terminal side is on either of the x-axis. And these are the ones that are not defined if our angles are terminal with the y-axis. Okay, just can't divide by 0. So wherever the first or second member of the ordered pair is 0. What else? Got another one? Let me go through number 10 right quick. My train of thought on problem number 10. On problem number 10, we're comparing in part A the sine of 50 degrees with the sine of 10 degrees. Now again, remember that sine is r over y. So if I fix r, I want to know which has the larger y. One way to fix r is to make it a radius of a circle. So let me put a circle here, and then a 10-degree angle would have some shape like that, and a 50-degree angle, maybe something like that. And I want to look at what the y values are there for the fixed value of r. Both of these have the same length of r. Now I want to compare the y values. Isn't it obvious that the y value at the bigger angle is a lot longer than the y value at the smaller angle? So that y compared to that y, the 50-degree y is bigger. Okay, it's opposite if I'm looking at the x's. If I look at this x for the 10-degree angle, it's bigger than the x for the 50-degree angle. So had I asked you to compare the cosines of those angles, the bigger the angle, the smaller the cosine in the first quadrant. In the second one, I want to know if the tangent of 200 is a positive or a negative number. So in part B, I'm just asking you that. Is the tangent of 200 a positive or negative number? Which quadrant is a 200-degree angle?
It's 30, so it's positive.
So it's positive. So there's your answer. You want a positive. The next one is the cofunction identity. The cosine of 52 degrees is equal to the sine of 90 minus 52, which is the 38 that I had in there. That's the cofunction identity. I'm looking for equals. The next one, I'm comparing the secant at 20 degrees with the secant of negative 20 degrees. Well, these are both acute angles. So the reference angle for a negative 20-degree angle is still 20 degrees. This angle's in quadrant 4, this angle's in quadrant 1. Secant is 1 over the cosine. Does the cosine change sign from quadrant 1 to quadrant 4? So they have the exact same value. They have the same reference angle, they have the same sign. Same reference angle, same sign. Okay? All right, give me another one. Got another one you want me to work?
You do number 9.
Number 9. Oh, this is what we're going to emphasize in this course. So let's go through these real carefully. Number 9. We want the exact value. So we need to know the reference angle and the quadrant so that we can get the value and the plus or minus sign. So 270 degrees, whether it's positive or negative, corresponds with a y-axis, right? So negative 270, that's negative 90, negative 180, there's negative 270. So it corresponds to something of the nature like that. It's a quadrantial angle. Sine is the y value. R is the same since it corresponds to that axis. And so sine is a positive 1. Y over R. The tangent of 300. In which quadrant is a 300-degree angle? Quadrant 4, because 360 corresponds to here, and 270 corresponds to here, so it's quadrant 4. Its reference angle is the difference between these two angles, so its reference angle is a 60-degree angle. And quadrant 4 is tangent positive or negative. It's going to be negative. And so I have to find now the value of the tangent of 60, or I can just take the sine of 60 degrees and divide it by the cosine of 60 degrees. I tried to base these numbers based upon what you put for me in the chart here. Most of you got this correct. And so the sine of 60 degrees is square root of 3 over 2. Cosine of 60 degrees is a half. The halves cancel, which makes the tangent of 300 degrees exactly equal to negative square root of 3. And now for the cosine of 240 degrees, tell me which quadrant we find 240 degrees. Quadrant 3. The reference angle is the difference between 240 and 180. So again, that's going to be 60. So I need to know the cosine of 60 degrees, and in quadrant 3, only the tangent is positive. Well, we just had the cosine of 60 degrees, that's a half. So our answer is minus a half. And then finally, the cosecant of 480 degrees. Since 480 degrees is larger than 360, I take the 360 out of there, and I find that this is coterminal with 120 degrees. 120 degrees is in quadrant 2. Cosecant is positive in quadrant 2. Agree? And the reference angle is the difference between the 180 and the 120. So by gosh, it's a 60-degree angle again. So it's 1 over the sine of the 60 degrees. Sine of 60 degrees was square root of 3 over 2. So you can write that as 2 over the square root of 3, and it's positive again. Okay? And it sure would help if you guys would show me some work. Just watch down the number. I can't tell if you know anything about reference angles or signs in which quadrant or anything like that. What else? I want to do number 14, part 2, because I was kind of picky on this one. Should have been picky-er. Number 14, part 2, I'm going to show you the picture. Some of you did this without a picture, so I don't know if you're trying to use right triangle trigonometry or just making up your own. Well, I probably shouldn't have given you much credit without the picture. Many of you caught me in a moment of weakness. I want your papers back if you don't have a picture, or I'll take some more points off. Okay, so we've got number 14, part 2. We got a ship traveling 10 miles on a bearing of 30 degrees. So remember that when bearings are given as a single number, they're measured from a north line. So I draw a 30-degree angle out here, and I make it go 10 miles. So let's make the length of that 10 miles. And now it's going to change and travel on a bearing of 120. So from here, I need a 120-degree angle measured clockwise. That would make it a 90-degree angle. That's 180, so it's somewhere in this neighborhood. And this one's going to be 20 miles, so if that's 10, there's 10, there's 20. And then I want the distance between these two. X. So many jump from that picture to the Pythagorean theorem. What I want to know is prove to me that that's a right angle. Yes, sir.
If you subtract 120 from 30, you'll get 90 degrees, which is between the 10 mile and 20 mile. That angle.
Why? How do you know? Where's this angle with respect to this? Why do I know that just subtracting those two gives me 90? Right? Can you tell me something about parallel lines cut by a transversal? I don't have any alternating interior. Here's my transversal if I wanted to stretch it, right? So I don't really have any alternating interiors. But what do we know about angles on the same side of the parallel lines inside the transversal? They're supplementary. So this angle plus that angle has to be 180. So this has to be 150 degrees. So these are supplementary because of the transversal and the parallel lines. And now I've got 150 degrees from here to here, 120 degrees from there to there. This completes a full circle. So those three measures have to add to 360. Well, 150 plus 120 is 270. To make this add to 360, that has to be 90. So that's what I was looking for. Only a handful of you gave me that justification that that was 90. Now that you have a 90-degree angle, the Pythagorean theorem comes into play. So now we can say that 10 squared plus 20 squared is x squared. I tried to give you numbers that didn't make you too queasy. Okay. So depending on whether I saw a picture or not, I gave you something 4, 5, 6 points to put out. The whole shebang if you gave me the picture. Okay. What else? You guys did really well. The average was somewhere in the neighborhood of an 87. So you guys would kick some booty on this one. So thank you. Our next test is October 19th. This again is an in-class test. I need everybody in class. Those of you who didn't take this first one in class, if you need to take another test not in class, you'll have to make arrangements to take it in the testing center. I had too many things I had to upload and download and convert. And, I'm still not done grading all of them. So you're not going to be in class. Make a schedule with the testing center and take it in person somewhere. We're ready to cover chapter 3. You ready to cover chapter 3? Or maybe just the first section? Which do you prefer? All of chapter 3 today or just one section? You're a bunch of weenies. Tired? Yeah. Students are always tired.
10
It
hours
does?
of class is not-
Ooh, that's impressive.
I like how you're the one that comes out with more energy than Al.
I'm just taking it.
Yeah, he's just like, no.
Take it, leave it.
If I don't like what's going on in here, how can I expect you to like it? Let's see what kind of geometry now. Sorry. Suppose I have a circle whose radius is 10. What's the circumference of a circle of radius 10? Circumference. It's got a pi in it. That's area. Anything squared is area.
Circumference is the perimeter.
Pi times diameter. So if the radius is 10, it's 20 pi.
I know it has something to do.
Right? So the circumference of an entire circle is 2 pi times r. Now, does that ring a bell?
Yeah.
Right? Anytime you tell me r squared, you're telling me area. R cubed, you're telling me volume. Circumference is a linear measurement. It's the measurement around. We know that if we take a ray from the origin and rotate it all the way around the XY plane so that it's back coterminal with the x-axis, then we've rotated that ray a total of 360 degrees. If we place that ray now on a circle of radius 1, that circle of radius 1 has a circumference of 2 pi times 1, or 2 pi radians. We're going to measure angles based upon fractions of laps around the circumference of a circle, 2 pi radians. So we're going to look at radian measure as opposed to degree measure. So we're in section 3.1. We're going to look at an introduction to radian measure. So we have measured in degrees, where we take a ray in a different color. Purple today. We take this ray and rotate it all the way around to there. That's 360 degrees. But if we think of the circle, whose radius is 1, that circle has as its equation x squared plus y squared is equal to 1. And it has circumference equal to 2 pi times 1, or 2 pi radians. So here's that circle. the circle x squared plus y squared is 1. So it intersects the x-axis at 1, 0. Then up here is 0, 1. Back here is -1, 0, and 0, -1. So if I walk all the way around there, I've gone 2 pi radians. We're going to look at measuring angles based upon fractions of all the way around or 2 pi radians. So we see that 360 degrees is equal to 2 pi radians. Or if I divide that equation by 2, 180 degrees is equal to pi radians. So I can say that a ray of measure 0 degrees corresponds to 0 radians. If I go all the way around, 360 degrees corresponds to 2 pi radians. If I rotate the ray only halfway around here, then that's 180 degrees. Half of 2 pi will give me pi radians. Now I want you to be able to play along. We are going to find the radian measure of all of our degree angles that we know and love. 0, 30, 45, 60, 90, blah, blah, blah. I'm going to find the corresponding radian measure of those. And so I have a copy of this unit circle, because I don't expect you to be able to draw as good as me, especially since you're just architecture majors, right? Engineering students. So I downloaded one. Yeah, there you go. And I have a blank one of these on Blackboard for those of you at home. If you want a unit circle, you'll have to download it from Blackboard. I feel like I'm in high school. We're going to do a worksheet today, maybe tomorrow, film strip. We'll bring the projector. You guys don't even remember that, do you? You guys don't even remember the teacher reeling in the projector and threading the.
I remember that.
I don't even remember from the Wonder Years or something like that on TV. Yeah. I remember when I first started teaching, we had to make copies with this little hand cranking machine. Okay, so I'm going to make this circle bigger so that we can all play a little bit better. So bigger, better. Right here is going to be bigger and better. See how big I can get it. Okay, so let's go back and label our ordered pairs on the axes. So again, it's the unit circle, so this corresponds to 1 unit right there. So up here is 0, 1, -1, 0, and 0, -1. So we had the ray that corresponds with the x-axis. There's a blank there that has a degree mark next to it. And then there's the next blank has radian marks. So this one corresponds to 0 degrees, which is 0 radians. And back here was 180 degrees or pi radians. This one, 90 degrees, was halfway between 0 and 180. So the radians is going to be halfway between 0 and pi. So that's just pi over 2 radians. A 90-degree angle corresponds to pi over 2 radians. I'm going to quit writing the radians. When you see the pi, it's in radians. Now, if I count my quarter circles as lengths of pi over 2, that means this arc here has a length of pi over 2, and the angle that has that measure here has a length of pi over 2. So if I count over, that's 1 pi over 2. This is 2 pi over 2, so the 2's would cancel. This then down here is 3 pi over 2. And 1 more pi over 2 puts me at 4 pi over 2, or back to 2 pi radians. So 360 degrees is 2 pi radians. Now we have ordered pairs there. In each of these cases, the R is the length of the ray. Heck, anywhere I put an R in this circle, R is 1, because it's the unit circle. So that means if R is 1, X over R, which is the cosine, is the first member of the ordered pair. Y over R is the sine. It's the second member of the ordered pair. So since R is 1, my ordered pairs will look like the cosine of whatever angle I'm talking about and the sine of the angle as ordered pairs. So for instance, the cosine of pi is the first member of the ordered pair back there. It's -1. The sine of pi over 2 is the second member of the ordered pair up there. It's +1. So anywhere on the circle, the X is the cosine, the Y is the sine, because R is just 1. So next we're going to look at the line Y is equal to X and Y is equal to -X. That cuts the first and third quadrants in half and the second and fourth quadrants in half. So let me make those in blue if this blue is going to work for me. It will. Y is equal to X. Smack dab through the first quadrant and third quadrant. That's drawn with a solid line on your circle. In degrees, those were 45 degrees. Those were half of the 90. So in radians, they're half of the pi halves. 1/2 of pi halves is pi fourths. So this 45-degree line here corresponds to pi over 4 radians. And I have now divided my entire circle into 8 chunks of length of 45 degrees. 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 times 45 is 360. But they're also thought of as pi over 4 chunks. So I'm going to add pi over 4. That's 1 pi over 4, taking me to here's 2 pi over 4. So the next one brings me to 3 pi over 4. And then finally 4 pi over 4. The 4's cancel, leaving me at pi. The next one should be 5 pi over 4. And 3 pi halves is the same as 6 pi over 4, if you were to reduce it. One more puts me at 7 pi over 4. And then 8 pi over 4 reduces to 2 pi. Now let's put the degrees in there. Let's each time add 45 degrees. Got the 45 here, got the 90. 90 plus 45 is 135. So this corresponds to 135 degrees. 135 plus 45 puts me at 180. 180 plus 45 puts me at 225. Add 45 to that, and I'm at 270 degrees. Add 45 to that one, and I'm at 315. And then finally, if you add 45 to 315, you're back at 360. Now, that was the line y is equal to x. It's on the line y is equal to x, and it's on the circle x squared plus y squared is 1. So let's see what happens to this equation if we replace y with x. When y is equal to x, I have x squared plus x squared is equal to 1. Can you see that? When y is equal to x. When y is equal to x on this circle, x squared plus x squared is 1. So I get 2x squared is 1. I'm solving for x. And I'm going to take the square root of both sides. Square root of 1 is 1, square root of 2 here. And we're used to rationalizing that one to be the square root of 2 over 2. That's the first member of the ordered pair right here. It's also the second member of the ordered pair. Y is x. So at 45 degrees, that point right there has as its coordinates square root of 2 over 2, square root of 2 over 2. And you know 45 degrees is our reference angle, so the other blue lines there have the same ordered pairs, but I just have to put a minus sign some places. Like back in here, at 3 pi over 4, or 135 degrees, x is negative, y is positive. So we put the ordered pair here as negative square root of 2 over 2, positive square root of 2 over 2. Negative x, positive y. What do you know about the x and y coordinates in quadrant 3? Both are negative. So let's put negative square root of 2 over 2 in both slots. Which coordinate is negative in quadrant 4? The y value is. X is positive. So we're going to label this one square root of 2 over 2, and the y value is negative. It's negative square root of 2 over 2. So what this order pair tells me is that the cosine of 7 pi over 4 is square root of 2 over 2. The sine of 7 pi over 4 is negative square root of 2 over 2. Okay. All right, next we're going to ignore the solid lines and we're going to look at the dashed lines. We'll look at the arcs for the dashed lines. Those are all 30-degree arcs. We cut this first quadrant up into 3 equal pieces. So if we ignore that and cut it into 3 equal pieces, there'd be about 1 here and about 1 there. These arcs here are 30 degrees. And they're drawn with dashed lines on your paper. So let me get out my black marker and draw me some dashed lines. So let me continue with that. That's 1, 2, 3. See, that's 30 degrees. Did you know that? So let's go another 30 degrees. Pink out here. That's 30. 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 And that's 30. So I'm going to connect my dots here. And the red will work. I'm going to do it with black. Okay, so I'm going to connect this dot with that dot with a dotted black line. Then I want to connect this dot with that dot through the origin with a dotted black line. See, aren't you glad I didn't make you draw this? Again. And then finally that one with that one. Now let's label those in degrees. I said they're all 30-degree arcs. See, now that's running into that. That needs to be moved up a little bit. So I'm just going to plumb take it off. We're just worried about the black dotted lines. So this one was going to be 30 degrees. The next one is 30 more, so that's 60 degrees. 60 plus 30 is 90. 90 plus 30 is 120. 120 plus 30 makes this dotted line down here 150 degrees. 150 plus 30 takes me to 180. Plus another 30 more takes me to 210. 210 plus 30 takes me to 240. 240 plus 30 takes me to 270. Plus 30 makes this one 300. This one's 330. One more 30 degrees brings me back to 360. That was hard to say. I want to see how many radians are in 30 degrees. Well, look what 30 degrees did. It took 180 degrees and broke it into 6 equal pieces. So if I take pi radians and break it into 6 equal pieces, then each of those 30 degrees is equivalent to pi over 6 radians. So we're going to label 30 degrees as 1 pi over 6. 60 degrees is 2 pi over 6, but that fraction can be reduced. 2 pi over 6 reduces to pi thirds. This is 3 pi over 6, but that reduces to pi halves. The next one is 4 pi over 6. 4 and 6 are both even. Divide by 2. 4 6 is the same as 2/3. So this is 2 pi over 3. Next one becomes 5 pi over 6. This dotted line at 150 degrees is 5 pi over 6. And then pi itself is 6 pi over 6. Keep counting. This dotted line now is 7 pi over 6. The next one is 8 pi over 6. But reduce that for me. 4 pi thirds. 9 pi over 6 is the same as 3 pi halves. 10 pi over 6 becomes 5 pi thirds. And this becomes 11 pi over 6 right here. 2 pi is the same as 12 pi over 6. What was the cosine of 30 degrees? Square root of 3 over 2. And the sine of 30 degrees? So that's the ordered pair right here. X is the square root of 3 over 2. Y is 1/2. So you should have a blank right there to put that ordered pair in. 60 degrees and 30 degrees are complementary. So the sine becomes the cosine becomes the sine. Swap the ordered pair. So the ordered pair right here has x as 1/2 and y is square root of 3 over 2. Let's stick with the pi over 6s though. Everything that is a pi over 6 has this ordered pair with the adjustment of a plus or minus sign. So if I go back over here to 5 pi over 6, what's the ordered pair right here? Which one's positive, which one's negative?
X is negative.
X is negative, Y is positive. So this ordered pair right here is the same as that, but X is negative and Y is positive. 5 pi over 6, your ordered pair is negative square root of 3 over 2, positive 1/2. The next pi over 6 I encounter is 7 pi over 6. It's in quadrant 3. X and Y are negative. So keep that ordered pair that you had in the first quadrant and make both of them negative. So I'm looking from a pi over 6. It's over here. In quadrant 4, X is positive, Y is negative. So I got a positive square root of 3 over 2 and negative 1/2. Now let's take all of our pi over 3s and write this ordered pair with a negative x over there, a negative x and y there, and a negative y here. So up here, the ordered pair is negative 1/2, positive square root of 3 over 2, My next one is here, both X and Y are negative. So the ordered pair here is -1/2, negative square root of 3/2. And over here, only the Y is negative. Negative, a +1/2, negative square root of 3/2. So on your unit circle, you have blanks up here for positive functions and negative functions. So let's go ahead and list them. I don't have them, but let's list them as if my circle were there. Our positive functions here are all of them. There are no negative functions. In quadrant 2, which trig functions are positive? And its reciprocal was cosecant of theta. The negative ones were the rest of them. I'll just write the rest of them. What about in quadrant 3? Which ones are positive? Tangent and cotangent. And in quadrant 4? Cosine and secant. Okay. But that circle gets awful cluttered. If you can remember what's going on in the first quadrant, then we can figure out the rest of it. Because those are our reference angles. And now it's easy to tell what a reference angle is going to be. If you have a fraction that has in its reduced form something pi/4, then pi/4 is your reference angle. If you have a reduced fraction that looks like something pi/6, pi/6 is your reference angle. You don't have to do any of that silly subtracting, but you do have to figure out what quadrant you're in. So if you know these and you can count either by thirds or sixes or fourths, then you can have a happy and healthy life. Happy. Healthy depends on how much sleeping and if you eat the right foods and exercise. Genetics. There's genetics too. Oh, and a pandemic. You're doomed. Good luck. So I'm going to write down some of our trig functions, and I'm going to put some angles in there. We have to decide what quadrant it's in and what the value is. Okay. So instead of having that circle looking at me, I'm going to do this back in table form. So let's rub off that old messy circle. Because mine, yours hopefully looks more organized than mine, especially if you have pretty colors. Look at you. So here's our table again. And this time we're going to do theta in radians. So 0 radians, pi/6, pi/4, pi/3, pi/2. If you're into degrees, 0, 30, 45, 60, 90. I'm going to put the cosine first this time, because remember, cosine is the x. And then I'm going to put the sine. Okay, so these are the numbers on the unit circle. Remember these first, 0. I'm going down the sine column. Then these are the other way. So cosine's x, sine is y. So, papers, where'd you go? let's look at, say, the cosine of 17 pi over 6. So 17 over 6 is reduced. So I know that the cosine of 17 pi over 6 is some version of square root of 3 over 2. I just have to decide if it's a positive version of it or a negative. Okay. So we got to figure out how do we know? Well, all the way around is 2 pi. So if I convert that to a something over 6, that's the same as 12 pi over 6. Agree? So that's got 12 pi over 6 in, take it out, and how much is left? 5 pi over 6, which is not quite 6 pi over 6. 6 pi over 6 is pi. So if this is not quite 6 pi over 6, which quadrant do you think it's in? Quadrant 2. So it's 12 pi over 6 plus 5 pi over 6. That's one full circle. And this is here in quadrant 2. In quadrant 2, is this particular trig function a positive number or a negative number? It is a negative number, and not just a negative number, it's the same as that number. So it's a negative square root of 3 over 2. All right, how about a sine of negative 3 pi over 4? We can still make negative radian measures just by winding our angle backwards. If I'm in fourths, one full lap around the circle is 8 pi over 4. Half a lap around the circle is 4 pi over 4. So I'm not quite all the way back to the negative x-axis. That puts me in quadrant 3. Agree? I know in quadrant 3, all of my trig functions, other than tangent and cotangent, are negative. On the pi over 4 lines, x is y. Those are where we had the square root of 2 over 2. $1, charge $1. $1 to get back in,
Okay,
and a 2-drink minimum.
I'll go outside back. I'll wait outside.
All right, let's do something over 6. Let's find a tangent. Give me an odd number. 11. Tangent of 11 pi over 6. We will need the sine of 11 pi over 6 over the cosine of 11 pi over 6. Any idea what quadrant you'd find 11 pi over 6 in?
4.
Because it's not quite 12 pi over 6, right? 12 pi over 6 is our one lap around. So it's just pi 6 short. That puts it in quadrant 4. In quadrant 4, is the tangent a positive number or a negative number? And so we get that negative number by taking my sine over the cosine. 1/2 divided by square root of 3 over 2. The halves will cancel, leaving me a -1 over the square root of 3. And you're probably used to seeing that rationalized as a negative square root of 3 over 3. Right? Okay. All right, somebody give me a 3-digit number. 411, a nice prime 3-digit number. All right, I'm going to divide it by 2. And let's see, we did sine, cosine, tangent. How about we do a cosecant? Cosecant gives us a 1 over which trig function? Sine of 411 pi over 2. So let's look at the pi over 2's. Right? What's pi over 2? Get down there. Let's look at, what am I pointing at? There's no pi over 2 in there. It's right here. Sine is a 1. So that's either going to be a positive 1 or a negative 1. We just have to figure out Is that coterminal with the positive y-axis or the negative y-axis? How can we possibly find out?
Subtract 306 and subtract 1.
Well, not 360. We have to keep taking out 2 pi. So why don't we write that as a mixed fraction? How many times does 2 go into 411? 205 and a half. So that's the same as 205 and 1/2 pi. So 205. I know where 200 pi will take me. Do you? 200 pi will be coterminal with 2 pi, wouldn't it? So now where would 5 pi take me? 5 pi, so 200 pi, oh, let's draw. Right, 200 pi will eventually take me to here because it's a multiple of 2 pi. It's 100 times around the circle. 5 is going to go 1, 2, 3, 4, 5 is here. And now I've got a 1/2 pi to go. So it's down here on the negative y-axis, which means the y-coordinate is a -1. Okay?
All right.
So it's easier. We don't have to really find a reference angle. The reference angle is talking to us right there. We just have to figure out a quadrant for which axis. Okay? Okay, now I'm just going to work with degrees and find radians. Not all of our degrees and radians correspond to these numbers here. Some of them are in between. How big is pi? 3.14. So if I drew an angle of measure 3 radians, it's going to be in which quadrant?
It would be
Right, there's going to be a difference in this angle. Suppose I want an angle of measure 3 radians and an angle of measure 3 degrees. Very different things. From here to here is 3.14 radians. So an angle of measure 3 radians almost hugs the negative x-axis. That's going to be in quadrant 2. 3 degrees is in which quadrant? Quadrant 1. There's 0 to 90 degrees in quadrant 1. So if I wanted to find the sine of 3 radians, that's different than the sine of 3 degrees. Agree? This is some positive number. I need my calculator to find it. And this is some negative number because it's in quadrant 2. So pay attention now. Without the symbol, the measurement is in radians. Not always will the pi be included. If you just see a number by itself, then we're talking about radians. If you see the little degrees, then duh, we're talking about degrees. Okay, so 2 pi, if that were as a decimal, 6.28. So if I said an angle has measure 7 radians, that puts it in quadrant 1, right? An angle of measure 5 radians, where would that be? 5 radians. If 2 pi is 6.28, I bet it's in quadrant 4, right? If you're to write pi halves as a decimal, take 3.14, divide it by 2. 1.57. Multiply that by 3, and that's about 4.2-ish. So 3 pi halves is 4.2-ish, right? So keep some of these decimals in mind for reference in terms of positives or negatives. Okay, let's look at converting angles from degree measure to radian measure and vice versa. So we want to convert degrees to radians, or radians back to degrees. And so what we have to remember is that 2 pi radians is equal to 360 degrees. Or if I divide through by 2, pi radians is equal to 180 degrees. So let's take 400 degrees and convert that to radians. So when you're converting units, you want to find a factor that will leave me the units I want on top and cancel the degrees. So let me write that as a little circle, so that the degrees would cancel and the ones on top remain. And this tells me I want pi radians here and 180 degrees there. So if you're going from degrees to radians, just multiply by pi over 180 and the degrees will cancel. All right, let's do the multiplying. First, I cancel the degrees. Then they're both multiples of 10, so let's cancel a 10. And 40 and 18 are both even numbers, so I can divide by 2. So how about 20 pi over 9? Is that okay? All right, the other way, suppose I have pi over 8 radians, and I want to know how many degrees that is. So then I've got radians here. I want radians to cancel, so I put my radians down here and my degrees there.
You do 180 over 5.
Do it just the other way, right? Put the 180 on top and the pi on the bottom. So that radians cancel this time, and we'll be left in degrees. So pi's will cancel. I have 180 over 8. Both of those are divisible by 4. 4 goes into 8 twice. 4 goes into 18 4 times, leaving me 20. So how about 45 over 2, which is 22.5 degrees. Okay. So to convert from radians to degrees, you multiply by 180 over pi. Let me see what else is in here. How many degrees is 15 pi? How many degrees is 15 pi? How many radians is 15 degrees? Those two, and then we'll call it a day. All right, you think you got them? Said to get rid of the radians, we multiply by 180 over pi. So 15 pi times 180 over pi cancels the pi. And now you multiply what? 180 by 15. So I'm here to help you with your arithmetic. It's 10 times 180, which puts a 0 on the end, and added to 5 times 180. What do you think 5 times 18 is? 90, then tack on a 0. So that's 2,700 degrees. All right, the other way. If I want degrees to cancel, I need the 180 on the bottom and the pi on the top. So degrees will cancel. 5 goes into both of those. 5 goes into 15 3 times. 5 goes into 18 3 times, but 15 from 18 leaves me 30. 5 times 6 is 30. So I have 3 pi over 36. That's reducible. 3 goes into 36 12 times. So I'm getting pi over 12 radians. Can I get both of those?
Yep.
Do you want our exam set?
No, the exams are yours. Put it on your fridge so that your roommates can see what you made. I'm gonna get you my work going. I haven't put it up there yet, but I'll put one on there.
You don't have to, it's fine.
I know I don't have to, but.
Don't need.
Thank you, guys. If anybody found any grading mistakes, bring them to my attention and I can fix them. Same thing at home, whenever you get your test back, make sure you check for grading mistakes. And I'll post the key on Blackboard.